Alright, this is section 7.2, which is solving quadratic equations that have imaginary solutions. You may or may not have dealt with imaginary numbers yet. But imaginary numbers are, I like to really call them complex numbers. They're non-real numbers. And we use these because there are applications for them in mathematics. And so complex numbers are usually of the form a plus bi. And a and b are numbers, like we're used to seeing. I stands for the square root of -1. So I is equal to the square root of -1. And we use that. There's a lot of times we use symbols for numbers. For example, pi stands for 3.1416. Later you're going to learn that e stands for a certain number. And so I just stands for the square root of -1. There's nothing really magic about it. It's just using a symbol instead of a number. The reason we have to do that is because if you put in the square root of -1 in your calculator, you're going to get an error message. You can't actually take the square root of a negative number. But if you had that number squared, in other words, if I have the square root of 2 times the square root of 2, that would be equal to the square root of 4, which happens to be 2. So if you notice, it's kind of like this radical here. When I multiply two square roots together, it's kind of like that radical lifts and goes away, and we're just left with what's underneath one time. So in other words, if I have I squared, then this is the square root of 2. Whoops. That's the square root of 2 squared equals 2. Okay? If I wanted to write it another way. So if I have I squared, that's the same as the square root of -1 squared, and then that actually has a value of -1. And so we have to in mathematics have made provisions to be able to handle when we do run into a negative under the radical. And there are actually ways to graph this on a complex coordinate plane. And that's not what we're going to do right now, but we are going to introduce the idea of this imaginary number I, because it's not real. You can't graph it on a regular Cartesian coordinate graph. The way we handle this is the square. For example, if you have this negative under a square root, like we have here, 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 and here, those are all negatives under a radical. We look at this like it's the square root of -1 times 5. Well, just like when we simplified radicals, we would take the square root of what we could take the square root. So I can take the square root of -1 and use the symbol I. I can't take the square root of 5, so it stays the square root of 5. So this is the final answer. That's the answer we're going to have when we have the square root of -5. So looking at number 2 here, alright, that's the same as the square root of -1 times 25. Well, I can take the square root of 25, and that's 5. And the square root of -1 I use as a symbol, I. So the square root of -25 is simply 5i. Okay. The square root of 45, again, let's break that down. That's -1 times 9 times 5. Okay, the square root of 9 is 3, so that comes out front. Square root of -1 is I, and usually put your number first and then the I. I can't take the square root of 5, so it stays under the radical. And so that's the square root of -45. Now the square root of 180, we might have to do a prime factorization. We know that 18, we know that we have negative 1 times 18 times 10. We know that. So let's see, 18 is 2 times 9, and 10 is 2 times 5. So let's kind of group some things together, all that square root. So that's negative 1 times 2 times 2 times 3 times 3 times 5. So there's a group of 2, and you can do it this way, or you can do the vertical prime factorization like I've taught you in the past. This is just another way of looking at it. Okay, so what do we have? Well, we have an I from the negative 1. The square root of this group is 2, and the square root of this group is 3. So that's going to be 2 times 3, or 6, that comes out from under the radical. And we're then left with the square root of 5. Okay, so 6i times the square root of 5 is your answer for the square root of negative 180. Okay. So, next, we're going to solve, and I'm going to go to the next page for this. We're going to solve this quadratic equation. Now, since you've learned how to put these in the calculator, let's do that and sketch the graph. Well, if we put this 5x squared plus 6x plus 5 in a calculator, and hit graph, you're going to get a graph that looks something like this. Notice, it does not cross the x-axis anywhere. When that happens, there are no real solutions to your equation. It never touches, it never crosses the x-axis. That means you're going to have a complex solution. And when you have a complex solution, you're going to have I in your answer. So let's go and see what we end up with. We're going to use the quadratic formula. So A is 5, and B is 6, and C is 5. Okay? So we have x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So x equals negative 6 plus or minus the square root. 6 times 6 is 36, minus 4 times 5 times 5, so that's 100. 25 times 4, and all of that's going to be over 2 times 5. Okay, so what you have then now, next, x equals negative 6 plus or minus the square root of negative 64 over 10. Okay, so now we've got this negative under the radical here, which means we're going to have an I in our answer. So x equals negative 6 plus or minus the square root of 64 is 8, and then the square root of negative 1, remember that's the negative 1 times 64, that's the same thing. So that's 8i over 10. Now, you can't combine your 6 and your 8 because 8, it's just like you can't combine a number and 8x. I couldn't add it if that was an x. I can't add it if it's an I. So it's the same sort of idea. But I can reduce this. I can divide everything here by 2. So my final answer is going to be negative 3 plus or minus 4i over 5. You still need to reduce that fraction. And then that's going to be your final answer. And that's a complex answer. If you wrote it in the form of the complex number, it would be negative 3/5 plus or minus 4/5 I. So you can write these either way. Okay. The real part is always listed first. The complex part, or the imaginary part, is listed second. Okay, so we have some other examples, and I'm going to just write those in. Okay, this next equation is 3x squared equals 5x minus 3. Well, you want to move over your 5x and your 3. So everything is equal to 0. So you have 3x squared minus 5x plus 3 equals 0. And so A is 3. B is negative 5. And C is also 3. Okay, so x equals negative 5 is going to be 5 plus or minus the square root of 5 squared minus, or negative 5 squared, excuse me, 4 times 3 times 3 all over 2 times 3. So x is equal to 5 plus or minus the square root of 25 minus 36 over 6. So x equals 5 plus or minus the square root of negative 11 over 6. Well, I can't take the square root of 11. That's a prime number. That's as simple as I can make it. But I can do something with this negative 1. And so my final answer needs to be 5 plus or minus I times the square root of 11 over 6. You always, if there's a negative under the square root, put I in front, because that takes care of the square root of negative 1. Okay. Now my next example is x squared plus 4x plus 16 equals 0. So A is 1, B equals 4, and C equals 16. All right, so x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 16 all over 2 times 1. Okay, x equals negative 4 plus or minus the square root of 16 minus 4 times 16, which is going to be (66), I believe, over 2. So that's negative 4 plus or minus the square root. Well, let me check that. That's not 66. 64. That should be 64. Okay, so this comes out to be negative 48 over 2. Okay. So now we're going to need to simplify under our radical a little bit. 48 is 16 times 3. So if I'm going to write that factored out, that'd be negative 4 plus or minus the square root of negative 1 times 16 times 3. That's the same as 48, negative 48. So x equals negative 4 plus or minus the square root of 16 is 4. The square root of negative 1 is I. You're left with the square root of 3 under the radical. And all of that's over 2. Now, this 4 will divide by 2, and that 4 will divide by 2. So I need to reduce the fraction. So my final answer is x equals -2 plus or minus 2I times the square root of 3. And remember, you just divide the number in front. You don't do anything to the square root of 3 when you reduce. And that's your final answer. Okay, so that's the end of 7-2.